The briefing room deep within the Pentagon was a temple of cold, hard truths. The year was 1968, and the air was thick with the scent of ozone, stale coffee, and a new, potent strain of anxiety. Men in crisp uniforms and dark suits studied the grainy, black and white photographs projected onto the screen. They showed a skeletal, almost insect-like aircraft, perched on a landing pad somewhere in the American Southwest. It had the general shape of a helicopter, but it was wrong. The tail was too long, the fuselage too slender, and instead of a traditional tail rotor, it had a shrouded fan and what looked like small jet engines. This, said a senior analyst from the Defense Advanced Research Projects Agency, his pointer tapping the screen, is not a helicopter. It is a compound rotorcraft. Lockheed calls it the Cheyenne. The name meant nothing to the Soviets, but the specifications, painstakingly pieced together by GRU intelligence offices from whispered conversations at aerospace conferences and blurry satellite passes, were rewriting the book on vertical flight. The Cheyenne was an attack aircraft, a hunter-killer designed to replace the R-1 Cobra, but its performance envelope was from another dimension. It could hover for hours, a stable, hidden sniper in the landscape. Then, with a roar from its auxiliary turbojet, it could accelerate to over 250 knots, faster than any helicopter in existence. It could climb at a rate of over 4,000 feet per minute, outpacing the climb of many contemporary Soviet fighter jets. It was armed with a chin-mounted 30mm cannon that could swivel independently of the airframe, and it could carry a devastating load of tow missiles. It was, for all intents and purposes, an invulnerable, omnipresent ground attack platform. In the analytical cells of the KGB's first chief directorate, the reports were met with a mixture of disbelief and cold dread. The Americans had not just improved the helicopter, they had reinvented it. The Cheyenne's secret was its rigid rotor system, a system without the complex, maintenance-heavy hinges of traditional helicopters. This allowed for incredible maneuverability and high-speed flight. Combined with its sleek, low-drag airframe and the punch of its turbojet, it was a system that could decimate Soviet tank columns from the flanks and rear with near impunity. Soviet analysts, struggling to categorize this new threat, gave it a simple, awestruck codename, Nevozmozhnaya Птица, the impossible bird. The message from the Kremlin to KGB headquarters at Lubyanka was swift and unambiguous. It bypassed the usual bureaucratic channels and was signed at the highest level. The directive was not a request, it was a command. The technological gap was unacceptable. They could not out-engineer the Americans in time. The Cheyenne was already flying, already being evaluated. The only solution was to acquire it. The order was a mere 5 words, but they carried the weight of the entire Soviet military-industrial complex: acquire the aircraft by any means necessary. Operation Zhar Птица, Firebird, was born. It was to be the KGB's most ambitious technological theft since the Manhattan Project. A special directorate was formed, reporting directly to the chairman. It was a multi-pronged assault on the Lockheed Skunk Works, blending classic espionage with cutting-edge technical intelligence. The team was a mirror of the Cheyenne's own complexity. Sparrows were low-level assets within the Lockheed supply chain, clerks, cleaners, and truck drivers. Magpies were mid-level engineers and technicians who could be blackmailed or bribed. And the Hawks were the elite, the deep-cover illegals and case officers who would run the operation from the shadows, their identities known only to a handful of men in Moscow. Their shopping list was exhaustive. They didn't just want the airframe, they wanted its soul. They needed the blueprints for the rigid rotor head, a masterpiece of machined titanium whose tolerances were a state secret. They needed the flight control software, the algorithms that tamed the unstable beast and allowed a single pilot to manage both rotorcraft and fixed-wing flight regimes simultaneously. They needed the performance data from the test flights at Area 51. They needed the metallurgical formulas for the special alloys used in the rotor blades. They needed the specifications for the T-53 turboshaft and the supplementary GET-64 turbojet. It was a heist of an entire technological ecosystem. The operation swung into motion with chilling efficiency. A Sparrow at a document storage facility in Burbank began smuggling out trash, which was sifted by KGB technicians in a safe house for any discarded engineering notes. A Magpie, a stressed-out engineer with gambling debts, was approached in a bar and presented with an offer he couldn't refuse: money for photocopies of stress analysis reports. In Brussels, a KGB operative posing as a Belgian aviation journalist conducted a seemingly innocent interview with a Lockheed executive, deftly steering the conversation towards vibration dampening in high-speed rotors. The information began to trickle, then flow, back to Moscow Center. A dedicated team of Soviet aerospace engineers, the best minds from the Mil and Kamov design bureaus, was sequestered in a secure facility outside Moscow. Their task was to analyze the stolen data and begin the process of reverse engineering the Cheyenne. They pored over the documents, their excitement growing. The design was brilliant, audacious. They began to see how the pieces fit together. They started drafting their own version, a Soviet, Cheyenne, that would neutralize the American advantage. But as the weeks turned into months, a subtle unease began to creep into the analysis. The data was too good. It was too clean, too complete. It was as if they were being fed the answers to a test. The pieces fit together a little too perfectly. There were no dead ends, no frustrating gaps in the logic. It was the opposite of the usual fragmented, contradictory intelligence that trickled out of Western black projects. The lead Soviet engineer, a brilliant but cynical man named Dmitry Volkov, was the first to voice the heresy. In a secure meeting with the KGB resident running the operation, he laid out his concerns. "Comrade Colonel," he said, tapping a stack of stolen documents, "this is a feast. But I am starting to suspect we are eating from a poisoned plate." The KGB officer scoffed. "You are seeing ghosts, Volkov. This is the product of a brilliant operation." "Perhaps," Volkov replied, his eyes narrowed. "But look here, the metallurgical report for the rotor spindle. The fatigue limits are specified to 3 decimal places. This is not a summary for general engineering use. This reads like an answer key. And here, in the flight control code, the comments are unusually verbose, almost pedagogical. It is as if they are explaining it to us." The KGB man dismissed him. The prize was too great, the pressure from the Kremlin too intense. They pressed on, ignoring the nagging doubts. The Americans, they were sure, were simply arrogant, sloppy in their security. They had gotten lucky. They were wrong. The problem they didn't know yet was that the Americans, specifically a small, paranoid cell within the Skunk Works led by the Cheyenne's chief designer, had anticipated them. They had designed the Cheyenne not just to fly, but to be stolen. They had baked a flaw into its very heart, a flaw hidden not in the physical hardware, but in the digital soul of the machine, a flaw that would only reveal itself when someone tried to build one from the plans. The KGB was not stealing a blueprint for a masterpiece, they were meticulously copying a forgery, and the trap was about to spring. The air at the Zhukovsky Flight Test Center was thick with the scent of kerosene and a palpable, unspoken dread. It was the autumn of 1969, and the Soviet Union's answer to the American Cheyenne, designated the Mi-28 Uragan Hurricane, was ready for its first flight. To the team of engineers from the Mill Design Bureau, it was a thing of brutalist beauty, a testament to their ability to steal a march on the West. To the man chosen to fly it, it was a sphinx with a riddle that had only one fatal answer. That man was senior test pilot Anatoly Grishchenko, a man whose nerves were said to be forged from the same titanium as the helicopter's revolutionary rigid rotor head. He had been decorated for his work on the treacherous Mi-6 and had a reputation for a cool, analytical detachment that bordered on the supernatural. As he walked towards the Uragan, the crunch of his flight boots on the tarmac was the only sound. He did not look at the small, hopeful crowd of officials. His eyes were locked on the machine. He approached it not with the swagger of a master aviator, but with the cautious reverence of a man walking toward a firing squad, unsure if the guns were loaded. The pre-flight briefings had been a litany of intoxicating promise and veiled warnings. The stolen data promised a machine that could hover with the stability of a kestrel, then leap forward with the acceleration of a striking cobra. But Dmitry Volkov, the lead engineer, had pulled Grishchenko aside. "Anatoly," he'd said, his voice low, "the numbers are perfect. Too perfect. The control laws in the fly-by-wire system. They are complex in ways I do not fully understand. The Americans are clever. Be precise." Now, strapping himself into the cockpit, Grishchenko felt the weight of those words. The cockpit was a confusing blend of Soviet-era clunkiness and stolen, sleek Western design. He went through the startup sequence. The massive turboshaft engine spooled up with a deep, powerful whine that vibrated through the airframe, a sound that promised either glory or oblivion. "Tower to Uragan 1. You are cleared for takeoff," Grishchenko acknowledged, his voice a calm monotone. He gently increased the collective pitch. The rotors bit into the air, and the machine lifted, light as a feather. For a single, perfect second, it was a miracle. The hover was rock steady, better than any helicopter he had ever flown. Then the Uragan spoke. As he began a slow, forward transition, easing the cyclic stick forward, the aircraft didn't just pitch forward, it seemed to lunge. The response was instantaneous, twitchy. Then, without warning, as the landing gear cleared 10 meters, the aircraft gave a sudden, violent shudder and began to roll to the right. It wasn't a gentle bank, it was an aggressive, snapping motion that threatened to invert the craft. Grishchenko's hands, trained by thousands of flight hours, reacted before his conscious mind could process the threat. He slammed the cyclic to the left, a hard, counterintuitive input. The roll arrested, the wings leveled. His heart hammered against his ribs. He had been airborne for 20 seconds. He continued the climb out, his senses screaming. At 300 kilometers per hour, a new demon awoke. A violent, high-frequency shudder began to rack the airframe. The entire cockpit vibrated, the control stick shaking in his hand like a live wire. The instrument panel was a blur. This was buffeting, the airflow tearing itself from the rigid rotor system, a warning of forces the system wasn't damping. He held his breath, riding the shaking beast, gently easing the nose down to gain more speed, to push through the turbulence. At 400 km per hour, the shaking stopped. The sudden silence was more terrifying than the noise. The cessation of the buffeting meant the aircraft was entering the high-speed transition zone, the realm where it was meant to become a compound aircraft, where the stub wings were supposed to provide lift and the jet engine was to take over. But the controls became hypersensitive. The fly-by-wire system, translating his inputs, felt like it had a mind of its own. A millimeter of stick movement was a command, a centimeter was an ultimatum. The nose hunted left and right, requiring constant, exhausting micro-corrections. He was no longer flying the Uragan, he was containing it, preventing it from executing its apparent desire to tear itself to pieces. For 50 agonizing minutes, Grishchenko wrestled with the machine. It was a continuous, draining battle of wills. Every neuron was firing, his muscles tense. The promised smooth transition to high-speed flight never came. It was a white-knuckle fight all the way to the edge of the envelope and back. When the fuel gauge finally dipped toward the reserve, he called for landing clearance. The approach was a nightmare. The aircraft, starved of the speed that gave its flight controls some semblance of authority, became a sluggish, yet still twitchy, handful. It wallowed, its nose hunting, the rotor disc feeling like it was on the verge of a retreating blade stall. He fought it all the way down, his body drenched in sweat. The wheels touched the runway with a jarring thud, not a smooth kiss. As the rotor slowed to a lazy whip, a profound exhaustion washed over him. The ground crew swarmed the plane. The canopy was hauled open. Grishchenko unstrapped and climbed out, his legs unsteady. He removed his helmet, his face pale and slick with sweat. The chief designer, Marat Mil himself, rushed up, his eyes full of desperate hope. Well, Comrade Grishchenko, the performance, the handling. Grishchenko looked at him, then back at the sleek, deadly machine that had just tried to kill him for nearly an hour. He took the offered clipboard and pen. The engineers expected a detailed report, control responses, vibration nodes, power settings. Instead, Grishchenko's hand, still trembling from the adrenaline, scrawled a single, stark sentence in the logbook. He thrust the clipboard back at Mill and walked away, not toward the debriefing room, but toward the solitude of the hangar, needing to be away from the eyes of men. Mill looked down at the paper. The sentence was short, brutal, and unequivocal. It was the pilot's verdict on the engineer's creation, a verdict that echoed through the ages of aviation folly. Honor Koshe Tebya Ubert. It wants to kill you. Grishchenko's flight was not the end. It was the beginning of a long, bloody baptism. His terrifying report was filed away as the predictable reaction of a pilot, however skilled, to a radical new design. The pressure from the Kremlin, desperate to field an answer to the Cheyenne, was immense. The prototypes, the Uragan 2 and Uragan 3, were rolled out, and the crashes began. The first was Uragan 2, piloted by a young, talented pilot named Sergei Yevtushenko. The mission was a high-speed dash at 500 meters. The data telemetry showed everything was normal until, at 420 km per hour, the aircraft experienced a sudden, uncommanded pitch-up. The nose reared back violently, a phenomenon the pilots were starting to call the Cobra Strike. Before Yevtushenko could shove the cyclic forward, the unstable airframe, now presenting its broad underside to the airflow, began to roll. The roll accelerated, turning into a sickening, flat spin. In a helicopter, a flat spin is almost always a death sentence. The rotors, caught in their own turbulent wake, lose all lift and authority. The ground telemetry captured Yevtushenko's final, strained transmission, a gasp, Cobra's Zakvatel. The Cobra has taken hold. The controllers watched, helpless, as the blip on their radar screen began a slow, fatal spiral into the Kazakh steppe. A chase plane pilot reported the grim sight. I see him. He's in a flat spin. No recovery. I see a parachute. No, it's a piece of the tail rotor. No parachute. The wreckage was scattered over 2 square kilometers. Sergei Yevtushenko was found still strapped in his seat. The official inquiry was a masterpiece of deflection. The engine was blamed, a suspected power surge from the T-64 turbojet that had overstressed the airframe. The fundamental flaws in the flight control software, the very system stolen from the Americans, were not mentioned in the final report. It was written off as a tragic, but acceptable, loss. The flight envelope has inherent risks, the report concluded, using the same chilling phrase that had followed the MiG-21. The incident parameters were within projected, acceptable limits for a test program of this nature. Within acceptable limits, became a mantra, a bureaucratic shield against the specter of failure. To admit the aircraft was fundamentally flawed was to admit the theft had been a catastrophic blunder, and to doom the careers and possibly the lives of everyone involved. Another prototype, Uragan 3, was lost a few months later, this time during a low-speed handling test near a hover. The pilot, a veteran named Boris Kornilov, was simulating a nap of the Earth approach, ducking behind a tree line. He reduced power and raised the nose to bleed off speed. The aircraft, its rigid rotor system starved for translational lift, gave one sharp, pre-stall buffet, and then the tail began to walk around the nose. It was a loss of tail rotor effectiveness, LTE, but it happened with a speed and violence that was unprecedented. Before Kornilov could lower the nose and add power, the aircraft pirouetted 3 times and slammed into the ground on its side. The fuel tanks ruptured and exploded. There was no ejection, no escape. The fire burned for an hour. Still, the program pressed on. The engineers made minor tweaks, adjusting control mixing ratios, tweaking the stability augmentation parameters, but they dared not touch the core of the flight control software, the crown jewel of their espionage coup. To do so would be to admit that Dmitry Volkov had been right, that the data was poisoned. Pilots were caught in an impossible bind. They were patriots, the best of the best. To refuse to fly the Uragan was career suicide and an act of political defiance. Yet, to fly it was to dance with the Cobra. They studied the wreck reports of their comrades, learning the fatal sequence, the sudden pitch-up, the uncontrollable roll, the flat spin. They promised themselves they would recognize the signs, that they would be quicker, smarter. But the Uragan was a teacher with no survivors. Each crash taught the same lesson, but the students who learned it were not around to share it. The aircraft kept flying, pushed by the relentless engine of state necessity and the sunk cost of a brilliant, disastrous theft. And the pilots, brave, terrified, and trapped, kept dying, their lives the currency with which the Soviet Union attempted to purchase a technology that was, by design, meant to self-destruct in the hands of a thief. The steps of the test ranges were littered with their sacrifices, silent monuments to an impossible bird that had led them all into a meticulously laid trap. The paradox of the Mi-28 Uragan was as stark as it was undeniable. It was a killer, but it was also a king. While its accident reports piled up in the locked Spetsgran, special archives, of the KGB, its performance reports were being celebrated in the halls of the Ministry of Aviation Industry. The very instability that made it a nightmare to fly was the source of its breathtaking, almost supernatural performance. The stolen flight control software, for all its hidden demons, contained algorithms for agility that Soviet engineers had never conceived. The rigid rotor system, while vicious near its limits, offered a level of responsiveness that felt less like flying and more like teleportation. In level flight, with its auxiliary turbojet screaming, the Uragan was a phantom. It could slice through the air at over 350 km per hour, a speed that made every other helicopter in the Soviet inventory look like it was standing still. NATO observers, tracking it on rare occasions when it was risked near the border, would watch in disbelief as the radar return accelerated away from their slower, more stable Hueys and Sea Kings with contemptuous ease. It wasn't just fast, it was fast now, with a jumpy, nervous acceleration that felt more like a missile than an aircraft. But it was in the vertical plane that the Uragan truly earned its devil's bargain. Its time to climb records were not merely broken, they were rendered obsolete. In a specific, highly classified test flight conducted after Grishchenko's near-death experience, a pilot flying the Uragan 4 prototype, fitted with temporary stability fixes, reached an altitude of 6,000 meters in a time that defied all conventional helicopter performance charts. Western intelligence, intercepting fragmented radar data and whispers from defectors, initially dismissed it as Soviet bluster. They could not conceive of a rotorcraft that could climb like a fighter jet. The Uragan could, and did. It was an interceptor in the purest sense. Its designed purpose was to lie in wait, hidden, then leap up to ambush high-flying NATO surveillance planes or to pounce on low-flying attack aircraft, its speed and climb giving the target no time to react. In this singular, brutal mission profile, it was, on paper, peerless. This created an agonizing schism within the Soviet Army Air Forces. In the dimly lit officers' clubs at Shkolovskaya and Tver, pilots spoke of the aircraft in hushed, fearful tones. They knew the names of Yevtushenko and Kornilov. They knew the specific, gruesome ways the machine had betrayed them, the Cobra's strike, the flat spin, the violent LTE. Yet, in the command bunkers, generals saw only the cold calculus of the Central European front. A dead pilot was a tragedy. A penetrated air defense, allowing NATO aircraft to ravage the advancing tank armies of the Warsaw Pact, was a catastrophe for the motherland. The Uragan's performance was a strategic asset that could not be discarded, a potential game-changer in the opening hours of World War III. It was General Mikhail Kolesnikov, the gruff, unsentimental commander of Soviet Army aviation, who finally articulated the brutal official stance. During a heated meeting where test pilots and frontline squadron commanders pleaded for the program to be halted, Kolesnikov slammed his fist on the polished table, silencing the room. "Enough of this cowardice," he roared, his face flushed. "We are not here to build flying tractors for milk runs. We are here to build weapons that can win a war." This aircraft is the most potent weapon we have ever put in the air. Is it demanding? War is demanding. The Americans with their Cheyenne are demanding. If our pilots must fear something, he declared, his voice dropping to a gravelly, menacing pitch, let it be our enemies, not our planes. The Mi-28 flies. It fights. It wins. The rest is a matter of selecting better pilots. The statement became a piece of ideological armor, a mantra used to bludgeon all dissent. But reality, as it so often did in the face of Soviet dogma, refused to listen to the generals. The wreckage of the Uragan III was still a blackened scar on the Kazakh steppe when the next batch of pre-production aircraft was delivered to a front-line attack helicopter regiment for operational evaluation. The pilots selected were not test pilots, but combat aviators, men trained for battle, not for exploring the ragged edges of a flight envelope drawn by a phantom. They were given a crash course and 2 familiarization flights in a docile Mi-2. Then they were turned loose in the Widowmaker. Faced with the mounting body count and the terrified mutiny brewing in the ranks, the engineers at the Mill Bureau were under immense, soul-crushing pressure. They could not simply rip out the stolen flight control software. The party and the generals would not allow a performance penalty, and besides, they didn't fully understand its Byzantine code. So they embarked on a frantic, almost desperate series of physical modifications, a brute force attempt to tame the beast without breaking its spirit. The first and most obvious target was the tail. The original design, a direct copy of the Cheyenne's, featured a sleek, swept vertical stabilizer with a canted tail rotor. It was elegant, but in the violent, uncommanded yawing moments, it was proving inadequate. They redesigned it, enlarging the vertical fin and adding a substantial, fixed ventral fin underneath the tail boom. This, in theory, would provide more directional stability and make it harder for the aircraft to enter a spin. It helped, a little. It didn't eliminate the Cobra strike, but it gave the pilot a fraction of a second more time to react. Next were the stub wings. The original wings were small, designed purely for high-speed lift, but they were also, the engineers suspected, interacting poorly with the rotor downwash during certain maneuvers, contributing to the pitch-up. They couldn't make major changes to the wing structure without a complete redesign, but they added a series of vortex generators, small, metal tabs on the leading edge, to try to smooth the airflow and prevent sudden stalls. They also reinforced the wing roots with additional rivets and strengthening plates, a tacit admission that the airframe was undergoing stresses far beyond what the stolen American stress analysis had predicted. The most significant, and most controversial, change was an attempt to shift the center of mass. They moved avionics racks, added ballast to the nose, and tweaked the internal layout to nudge the center of gravity forward by several centimeters. The effect was immediate and tangible. The aircraft became slightly less twitchy in pitch, slightly more predictable. But the improvement came at a cost. That slight forward shift increased the aircraft's static stability, which in turn increased the load on the tail rotor and slightly degraded its blistering, snake-like agility. The engineers were walking a razor's edge, trading just enough safety to keep pilots alive without surrendering the performance that made the aircraft strategically valuable. Finally, they addressed the vibration. The rigid rotor system, while capable of high speed, transmitted every shock and tremor directly into the airframe. This wasn't just a comfort issue. It was fatiguing the metal and confusing the sensitive flight control senses. They installed a new, improved dampening system between the rotor mast and the airframe, a complex arrangement of hydraulic shocks and rubber isolators. It was a band-aid on a fundamental characteristic of the design, but it smoothed out the ride just enough to reduce pilot fatigue and give them a better chance of sensing the aircraft's true attitude. Each modification helped. Each one saved a few lives. The accident rate, while still horrifying, began to level off from its initial, apocalyptic peak. Pilots learned to fly with a new, hyper-vigilant style, their hands constantly making tiny, unconscious corrections, their feet dancing on the pedals. They developed their own folklore, their own saints, to pray to before a flight. But the engineers, in their heart of hearts, knew the truth. None of their fixes solved the core problem. The Mi-28 Uragan was born from a radical philosophy stolen from the Americans, that ultimate performance in a rotorcraft could be achieved by designing an airframe that was inherently unstable, relying on a digital brain to make thousands of corrections per second to maintain control. This philosophy was a generation ahead of its time. It was only in the 1980s, with the advent of powerful, redundant digital fly-by-wire systems, that this concept became not just feasible, but standard. In aircraft like the American R-64 Apache, the airframe is designed with stability in mind, but the flight controls are fully computerized, providing a smooth, responsive interface. The pilot is a tactician, not a high-speed stability augmentation system. But in the late 1960s and early 1970s, the Soviet Union lacked the sophisticated, miniaturized computing technology to build such a system from scratch. The stolen software was a ghost in their machine, a set of instructions they could copy but not truly comprehend. running on hardware that was a clumsy imitation of the West. The Uragan was a machine from the future, delivered to a past that lacked the technology to control it safely. It demanded superhuman skill and offered, in return, a glimpse of a new kind of aerial combat, a glimpse that, for dozens of young Soviet pilots, was their last sight on Earth. They were analog pilots, strapped into a digital aircraft they could not understand, and the mismatch was paid for in blood and fire, scattered across the vast, unforgiving landscape of the motherland. The legend of the Uragan's lethality had cast a long, dark shadow, but it was a shadow thrown by a towering peak of performance. That peak had yet to be truly scaled, its ultimate limits probed in a single, definitive flight. The generals demanded proof that the blood price was worth it, a spectacular, undeniable triumph they could wave in the face of the Politburo and the weeping widows. The man chosen for this mission was not the bravest pilot, nor the most reckless. He was the most precise. His name was Alexander, the Professor, Karpov, and he was known for a preternatural calm that bordered on the robotic. Fear was a variable he had apparently deleted from his personal equation. While other pilots white-knuckled the cyclic, Karpov's hands were steady, his breathing even, his mind a cold, analytical computer processing data, not emotion. He was the only man the Bureau trusted to ask the Uragan its ultimate question. The day was meticulously planned, the airspace over the remote Sari Shagan test range cleared of all traffic. The atmosphere in the concrete control bunker was funereal. The lead engineers chain-smoked, their faces pale. The telemetry technicians spoke in hushed tones, as if a loud noise could upset the delicate balance of the aircraft miles away. Karpov, in the cockpit of the specially prepared Uragan 5 prototype, the one with all the stability modifications, went through his checks with methodical slowness. The aircraft had been lightened, its fuel load calculated to the gram, its engines tuned to a razor's edge. It was a bullet, and Karpov was its firing pin. All systems are green, his voice crackled over the radio, flat and devoid of inflection. Requesting clearance for high-altitude performance run. Cleared, Uragan 5. The sky is yours. There was no gentle ascent. Karpov pulled pitch and pushed the throttle for the auxiliary turbojet to its stop. The aircraft leaped upward, not climbing so much as escaping the earth. The acceleration was a physical blow, pressing him into his seat. He climbed not in a gentle arc, but like a homesick angel, the nose pointed at the zenith, the thin air offering little resistance. The vibration was a constant, teeth-rattling hum, a reminder of the rigid rotor's brutal efficiency. The airspeed indicator needle began to crawl, then to sprint. 350 kilometers per hour. 380. 400. He was pushing into a speed regime no Soviet helicopter had ever touched. At 4,000 meters, he leveled off, the world below a curved panorama of brown and green. This was the moment. He had to push it further, into the realm where the rotor tips were approaching the sound barrier and the airframe was groaning under combined G-forces and vibration. He nudged the throttle forward again. The engine screamed in protest. A new, deeper vibration started, a resonant shudder that felt like the airframe was tuning itself to a fatal frequency. The controls, already hypersensitive, became almost telepathic. A breath on the cyclic was enough to send the nose yawing. He was flying on the edge of the flight control software's capability, in the zone where its hidden, poisoned logic could trigger at any moment. The telemetry station in the bunker went silent. The data streamed in, a river of numbers flowing across the green phosphor screens. Airspeed, rotor RPM, engine temperature, G-load. The senior engineer, a man named Yuri who had championed the project from the start, stared at the primary screen, his mouth slightly agape. He's past 420, he whispered, the cigarette forgotten in his hand. He's past the projected maximum. He's still accelerating. The numbers kept climbing. The aircraft was flying faster than any rotorcraft in the Soviet inventory, faster, they believed, than the American Cheyenne itself. It was outpacing its own theoretical limits, a silver dart hurled against the firmament. The stress on the airframe was immense. The telemetry showed loads on the rotor head approaching the absolute limits of the titanium alloy. One slip, one tiny control surface flutter induced by the rogue software, and the aircraft would come apart like a cheap toy. In the cockpit, Karpov was a statue of concentration. His world had narrowed to the instruments and the feel of the machine. He was not fighting it, he was conducting it, a maestro leading a volatile orchestra in a symphony of speed. He knew the stories, the cobra strikes, the flat spins. He felt the aircraft's malevolent potential in every shudder, every twitch. But he also felt its awesome, stolen power, a raw, untamed force that answered his will with absolute obedience, so long as that will was perfect and the hidden trap in its code remained unsprung. After what felt like an eternity, the fuel reserves triggered the warning light. Gently, with infinite care, he began to reduce power, to let the beast cool, to bring it back from the edge of the envelope. The descent was as tense as the climb, a controlled fall back into the thicker, more turbulent air where the Uragan's vicious temperament was most pronounced. When his wheels finally kissed the dust of the sorry shag and tarmac, a collective, held breath was released across the airfield. The ground crew swarmed the aircraft, which ticked and pinged as it cooled, steam rising from its hot engine cowlings. Karpov brought it to a stop, shut down the engines, and went through the post-flight shutdown drill with the same methodical calm as before. The canopy was hauled open. He unstrapped, climbed out, and descended the ladder. The chief designer and the lead engineers rushed to him, their faces etched with a mixture of awe and apprehension. They had seen the data. He had shattered the record. He had done the impossible. Karpov removed his helmet. His face was impassive, save for a faint sheen of sweat on his brow. He looked at the men, then at the aircraft, now silent and still, like a spent cartridge. "Well?" the chief designer asked, his voice trembling with anticipation. "How was it?" Karpov's analytical eyes scanned the length of the fuselage, taking in the subtle signs of the stress it had endured. He did not smile. He did not celebrate. He delivered his verdict not as a triumph, but as a clinical diagnosis, a coroner reporting on a temporarily resuscitated corpse. "It will kill many more," he said, his voice quiet and flat. But today it obeyed. It was the most chilling endorsement imaginable. He had proven the aircraft's world-beating potential, but in doing so, he had confirmed its fundamental, unforgiving, and treacherous nature. It hadn't been tamed, it had merely been placated, for a moment, by a master who understood its language of violence. Karpov's flight should have been the culmination, the justification for all the pain and sacrifice. The Mi-28 Uragan had proven it could achieve the impossible, securing a vital propaganda victory and a tangible military edge. The investment was colossal. The production lines in Rostov were being tooled. The blueprints for hundreds of aircraft were finalized. The party was ready to celebrate its new champion, a symbol of Soviet ingenuity, never admitting it was stolen, and might. But a quiet counter-current was building, one that no amount of performance data could silence. It was the sound of grief, and it was growing into a roar. The funerals had become a constant, grim ritual. They were not for old men who had lived their lives, but for young men in their prime, cut down not by an enemy, but by their own equipment. The whispers in the officers' clubs had turned into a low, persistent rumble of discontent that even the KGB could not fully suppress. The most talented pilots, the very men the state needed to fly this wonder weapon, were beginning to actively scheme to avoid assignment to Uragan regiments. Morale was crumbling into dust. The final, decisive blow came from an internal report so stark in its conclusions that it bypassed the usual layers of optimistic lies. Compiled by a colonel in the personnel directorate who had lost his own nephew to the Cobra strike, it landed on the desk of the commander-in-chief of the Soviet Air Forces. It was not a technical document. It was a human one. It contained the service records of the dead, their photographs, the letters to their families. It described the psychological profiles of the surviving pilots, their skyrocketing stress levels, their superstitious rituals. And it concluded with a sentence that bypassed all political and technical jargon to deliver a simple, devastating truth that echoed through the opulent, silent offices of the High Command: Vertolet, Kotrii Boritsia so swoim lechikum, eni Yavlietsia Vertoltum. A helicopter that fights its pilot is not a helicopter. The phrase was unassailable. An aircraft was a tool, an extension of the pilot's will. A hammer that unpredictably smashed the carpenter's thumb was not a good hammer, no matter how hard it could hit a nail. The Mi-28 Uragan, for all its stolen speed and climb, was fundamentally flawed as a weapon of war. It consumed its own operators at an unsustainable rate. In a prolonged conflict, the Soviet Army aviation would run out of pilots long before it ran out of helicopters. The decision, when it came, was a shockwave that reverberated through the entire Soviet military-industrial complex. There was no public announcement, no fanfare. A top-secret directive, stamped with the seal of the Central Committee, was delivered to the Mill Bureau and the relevant production ministries. The Mi-28 Uragan program was cancelled. Immediately, all further development was to cease. The prototypes were to be grounded, their data sealed. The name, Uragan, was to be expunged from future manuals and records. The designation Mi-28 would be reserved for a future, entirely new design. The order was not born of a lack of speed, or of obsolescence. It was a rare, stunning moment of human sense and logistical pragmatism overriding cold, technological ambition and national pride. The Soviet Union, a state capable of immense brutality, had looked into the abyss of the Widowmaker and, for once, blinked. They could not ignore the funerals anymore. The production lines were retooled for more Mi-24 Hinds, the rugged, stable, if less spectacular, workhorse of the Soviet air cavalry. The knowledge gained from the Uragan was not entirely wasted. Lessons about rigid rotors and compound flight would slowly filter into future designs like the Mi-26. But the Uragan itself, the impossible bird, was dead. The prototypes were quietly dismantled, their parts scavenged, their airframes melted down. They disappeared into the memory hole of Soviet history. But they were not forgotten. In the hushed conversations of old pilots, in the hangars where the dependable Hinds were serviced, the legend lived on. They spoke of it not with hatred, but with a kind of terrified reverence. It was the helicopter that could have ruled the battlefield, a monster of pure performance that was simply too perfect, too demanding, and too treacherous for the men who had to fly it. It was a ghost, a warning, and a benchmark, the machine that broke all the records, and all the men who weren't quite good enough, or lucky enough, to survive it. The legacy of the aircraft, known only by its grim sobriquet, the Widowmaker, is one of profound and haunting contradiction. It was, by any measure of operational service, a catastrophic failure. It was withdrawn from production, its name stricken from the records, its very existence an embarrassment to the system that created it. Yet, in the silent, hallowed halls of aviation history, it is regarded not as a mistake, but as a masterpiece of flawed genius. It was a bridge, a terrifying, rickety span thrown across a chasm between two distinct eras of flight. On one side of that chasm lay the past, the era of stable, predictable, forgiving aircraft. These were machines like the MiG-15, the F-86 Sabre, and the Supermarine Spitfire. They were designed with a generous margin of stability. If a pilot took his hands off the controls, the aircraft would, of its own accord, return to straight and level flight. It wanted to live. It was a partner, a trusted steed. Its control inputs were heavy, deliberate, and dampened. Flying it was an act of command. On the other side lay the future, the era of the F-16 Fighting Falcon, the Su-27 Flanker, and the Eurofighter Typhoon. These are aircraft that are, by their very nature, unstable. They are designed to be aerodynamically, squirrely, poised on the very edge of control. This inherent instability makes them incredibly agile. They can change direction with a speed that seems to violate physics, pivoting around their center of gravity like a hummingbird. But this agility comes at a cost. They are impossible for a human to fly unaided. They require a digital guardian angel, a fly-by-wire computer system that makes thousands of microscopic corrections per second, translating the pilot's rough commands into the precise, delicate control surface movements needed to keep the aircraft from tumbling out of the sky. The pilot is no longer a direct flyer. He is a systems manager, a commander who issues intent to a computer that executes the complex, high-wire act of actual flight. The Widowmaker was that future, delivered prematurely to the past. It was the first true attempt to build an inherently unstable combat aircraft. Its designers at the Mikoyan Bureau understood the physics perfectly. They knew that by pushing the center of gravity aft, by using razor-thin wings, they could create a machine of unparalleled performance. What they could not create was the digital brain to control it. In the 1950s, the technology for a reliable, lightweight, and powerful flight control computer did not exist. The vacuum tubes and primitive transistors of the era were too slow, too heavy, and too fragile for the brutal G-forces and temperature extremes of a fighter cockpit. Answer: they did the only thing they could. They made the pilot the computer. They strapped a man, with his biological lag, his human nerves, his finite capacity for concentration, and his susceptibility to fear, into the cockpit and tasked him with performing a function for which he was evolutionarily unsuited. He was asked to become a real-time, analog flight control system, to make those thousands of corrections per second not with silicon and electricity, but with muscle and bone and intuition. Some, like Ilyushin, could do it for a short, glorious while. Most could not. The Widowmaker was not evil. It was not cursed by some malevolent spirit. It was, as the surviving engineers would later admit in hushed tones after the fall of the Soviet Union, simply too advanced for its time. It was a jet engine in the age of propellers, a satellite in the age of balloons. It was a solution to a problem, whose creation introduced a new, more deadly problem. Its legacy, therefore, is not found in its combat record, for it saw none. It is not found in the squadrons of the Soviet Air Force, for it was never deployed. Its legacy is etched into the very DNA of every modern fighter that followed. The painful, bloody lessons learned from its crashes and near misses were studied not just in Moscow, but eventually, through espionage and analysis, in Fort Worth, Texas, and in Moscow. When American engineers began designing the F-16, they had the ghost of the Widowmaker looking over their shoulders. They understood the performance benefits of instability, but they also understood the absolute, non-negotiable necessity of the digital intermediary. The Widowmaker had drawn the map. The F-16 had the vehicle to travel it. It was a failure that paved the way for every success that followed. It was a monster that frightened its own pilots, a machine that seemed to possess a malevolent will, earning a nickname born of dread and respect. Yet, it was this same monster, this Widowmaker, that broke the records the USSR so proudly displayed to the world. Its speed and climb rate were not just numbers on a page, they were statements of intent, proof that Soviet science could push beyond the known boundaries. The same aircraft that generated telegrams of condolence also generated headlines in Pravda, boasting of Soviet technological supremacy. This is the final, enduring paradox of the Widowmaker. It was both a national triumph and a national shame. It was a symbol of breathtaking ambition and of catastrophic human cost. It stands as a permanent monument to a simple, brutal truth in the history of technology, that the cutting edge is, by its very nature, a sharp and dangerous place. Progress is not a gentle slope upward, but a series of violent leaps, and sometimes, those leaps are made by those who cannot see the other side, who fall into the abyss, their sacrifice marking the path for those who come after with better tools. The Widowmaker was that leap. It was a masterpiece that failed, a deadly work of genius that taught the world how to fly.